Good morning. Audio and video are clear. Yes, yes. Thank you. So yesterday we have disturbance, poor internet connection, right? So maybe you are clear about presbyopia or not, I don't know. Just give me your response. Shall I repeat presbyopia or continue to differences between presbyopia, hypermetropia? So no need of explanation that, right? So we'll go for differences. So before that, I will just remind you about presbyopia. Here, presbyopia simply by the age, right? So that's why it is called as aging defect. Mainly, it is weakness of ciliary muscles. This defect mainly because of ciliary muscles, right? So here they cannot accommodate focal length of the eye lens. That's why it is unable to adjust the minimum focal length or maximum focal length. So the focal length lies between 2.27 and 2.50. Weakness of ciliary muscles causes this cause of this defect. So in this, that person is in this defect, it is difficult to see the far objects or the near objects. Right here, mainly ciliary muscles are cause. Right here, the lenses are suitable to correct this defect combination. Actually, myopia will be corrected by particular lens called concave, and hypermetropia corrected by using the convex lens. So we can use for this defect correction combination of concave and convex. Right. So it is called as bifocal lens. Here, this defect also called as combination of myopia and hypermetropia. These are the points we discussed. Suppose if the defect differences are asked, I have myopia to hypermetropia, or hypermetropia presbyopia, or myopia presbyopia, any combination, just what you know about the defect, that only write as point wise. For example, I know myopia. What here it is called as nearsightedness. Okay, first point I can write as like that. This defective person able to see near objects clearly, but cannot see the far objects. Right. Second point. Then third point, in this defective person, here the person is able to see up to a maximum distance in front of him. That point we can call it as far point. Then here the person defect will be corrected by using the concave lens. Like this, I can add the points. Then in this, the focal length maximum is 2.50, but minimum is 2.270. Maximum is less than 2.50. So that points I know about myopia. So that I can write. Then hypermetropia, exactly opposite, right? So if you add points like that, you can write the differences. No need to prepare any specially answer. What you know, that only you can differentiate between two defects as point wise. So if you observe this table, you have that point only. For example, here, see, nearby objects are visible clearly, but not far away, right? Also called as short-sightedness. Here, hypermetropia, far-sightedness. Here, to fix the myopia, correction, unfix, right? That what we can use a double concave lens, where the image will be formed in the myopia defect, it is before the retina. In the hypermetropia, beyond the retina. Like this, you can write the points for differentiating the defects. Are you clear how to write the differences between myopia, hypermetropia? Give me a response. If the question come in your examination, how you differentiate between myopia and hypermetropia, without preparation, you are able to write. Because you already practiced diagrams to name the defect, right? So based on that knowledge only, we can write the differences, right? The next term here, if it is asked to write the difference between hypermetropia and presbyopia, what we can write, same thing, what we learned. In the hypermetropia, we know that defect, right? So here you are comparing hypermetropia and presbyopia. Presbyopia because of age, but hypermetropia not because of age, right? So here that age comparison we have to write. Okay, so hypermetropia, it is not because of age, but presbyopia, it is because of age. Here, that age above 40, presbyopia, that hypermetropia below 40 years age, right? Here, it may be hypermetropia, it is from by birth also, but presbyopia after the certain age only. Okay, here, simply here in the hypermetropia, the shape of eyeball, right? Shape of eyeball is unusual, right? Or it may be depends on the lens, or maybe depends on the outer layer cornea, right? Many reasons are there to get the hypermetropia defect. But there is no these type of observations in the presbyopia, right? Here for what hardening of lens and weakening of ciliary muscles are not cause, right? Here, cause is hardening the lens and weakening the ciliary muscles over time. Here, within the less time, it maybe becomes in hypermetropia, but it takes more time in presbyopia. So like this, we can write the defects in this, right? If you want, take a screenshot. If you want, take a screenshot, right? So these are the differences, right? Then we'll go for the next topic is that is power of lens, right? So before going that, I'll give you different types of lenses we use in our specs, right? To correct the different defects, right? So usually single lens we may use or combination of two lenses we may use. So here in the specs, we can use single lens to correct the defect, which is only one. That may be far visibility clear, near visibility not clear, or near visibility is clear, far visibility is not clear. For them, we can use only one type of lens. That may be concave lens or maybe the convex lens, right? So for them, we can use only single lens. If they are suffering from the defect, unable to see the nearer object, unable to see the far objects, for them, we can use a double bifocal lens, right? So here, simply in the bifocal lens, we have two lenses combination, right? Two lenses combination. Okay, here, upper and lower portion, right? So upper portion is to see the distant object, lower portion is to see the nearer objects. So here to correct this defect, here to correct this defect, here maximum we can use to correct the defect near visibility. What type of lens we can use here? Double convex lens. What about this to see the distant object? Concave lens we can use. So generally in bifocal lens, what we can use? Lower portion is by the convex lens, upper portion will be with the concave lens, right? Then one more lens is trifocal lens, right? So here to see the distant object, intermediate and near, right? So these are the type of lenses usually used in the specs. Okay, then how to select this lens, right? Based on the focal length. Well, based on the focal length. Okay, here doctor will not prescribe you that based on the focal length. They can use different terminology, right? They can use the different terminology. What that, right? So that we can call as here power of lens. What is actually power of lens? In a lenses only, we learned about converging and diverging of lenses. Anybody remember that what is converging and what is diverging of light rays? Anybody? Converging, diverging. Can anybody repeat? What is converging? What is diverging? Converging means after refraction, they can meet actually by the refracted light rays. If you get a converging point, that means they can meet each other at a common point after refraction. So actual rays are going to coincide each other at a point. That point we can call it as converging point. If not, we will go in the backward direction. They appear to diverge from a point. That point we can call it as diverging point. So here, according to that, we have two types of lenses. One is converging lens and the other is diverging lens, right? So that depends on the type of lens, right? And its strength, the ability of converging or diverging of light rays by the lens. So we are not able to directly converge the light rays without using lens. Are you? Can you diverge or converge the light rays without using lens? That means refraction without using the lenses. Possible to you? Without using the lens, can you bend the light rays? Answer my question. No. We are unable to bend the light rays without using the lenses. So that bending of light rays maybe give you converging point or diverging point. So that can be achieved. So here, how effectively you are converging the light rays or diverging the light rays, that is only here power of lens, right? So in this topic, we will learn what is power of lens, right? What is power of lens? Then what is the relation between the power of lens and the focal length? We will learn what is power of lens, what is the relation between the power of lens and the focal length, and what are the units to express the power of lens. Finally, how to find the power of lens, right? So here we can use a formula to find out the power of lens. And by knowing the power of lens, you are able to identify the type of lens also, right? These are the 5 different concepts we are learning in the power of lens. One is what is power of lens, the relation between the power of lens and the focal length, what are the units of power of lens, how to find the power of lens, finally, how to identify the type of lens by knowing the power of lens. So these are the concepts I will explain you in the power of lens, right? So here, first of all, I need to know what is power of lens here. The definition of power of lens. So how to define power of lens here? Do you know what is power of lens? Anybody here? I don't know, but that power, how I am identifying what is actually use of lens? Can anybody? What is use of lens actually? Why I'm using lenses? Why I'm using lenses? To observe the phenomenon of light called refraction. Refraction is what? Bending of light rays. So that bending light rays will give you a common point by actual light rays, right? Or its backward light rays. That only here, converging point or diverging point. So that I am achieving by using the lens. Are you clear? Are you clear what I am trying to say? No? Here simply suppose if I have a lens. Here look at the screen. I'm taking a lens here, right? Whatever it may be the type of lens here. Suppose one of the lens is taken. Without using this lens, can anybody bend the light rays or change the direction of light ray? Possible to you? Is it possible to you? No possibility, right? If I use this lens, right? If I use this lens, what happens on refraction? That goes like this, right? If I consider one more ray like this, what happens? Again, it is going to bend like this, right? So I'm getting a common point here. I'm getting a common point by the actual light rays. They can meet each other. So this point I'm calling as converging point. Can you achieve this without using the lenses? Can you achieve without using the lens? Can you bend the light rays without any change in the medium? Impossible. So that I am trying to say here, right? Then now I want to bend this light ray further, right? I want like this. I want to change the converging point to here. Is it possible to me? Is it possible to me? Answer my question. I want to change this converging point here. Is it possible or not? Respond. I want the converging point here. Can you change that focus of the lens? Or I want to change that focus to here. Can anybody change this? Sorry. Like this, what you are able to see for the same light ray. For the same light ray. Can you achieve? Answer my question. Unmute option is given you. Are you able to do this or not? There are no condition applied here. You can achieve. But here what to do? You need to change the lens. Yes or no? If I change the lens, that maybe give you the converging point below or beyond. Is it possible or not? If you change the lens, then you can imagine with the concave lens. Concave lens will give you diverging point. So that diverging point also you are able to change using the different lenses. Are you clear? Are you clear now? What is the difference to get this converging point inside or outside this red colored spot? Here simply that angle is different, right? That angle is different. Yes or no? Yes or no? I am bending more or less. So angle of refraction is changing. So that achieved by using the different lenses. So here that strength of the lens is different to bend the light ray. How effectively it can bend, right? So that is only called as power of the lens, right? That is only called as power of the lens. So this can be achieved by a lens only, right? This can be achieved by a lens only. So here, what is power of lens means simply here that bending of light rays only. How in terms of angles I am expressing that. The degree of what bending of light rays give you converging or diverging point. So convergence of light rays or divergence of light rays. Are you clear? How I am given the definition? I am not remembered. Just I observed what bending of light rays, right? With the different lenses. Bending of light rays with the different lenses with the parallel beam of light ray only. So that can be achieved, right? That can be achieved differently. What? Towards a point called focal point. That focal point is changed, right? So the degree is changing that. So here, that what exactly I am saying here, power is different. What power? It's strength to bend the light ray. So that is only here we are defining as power of lens. So here power of lens is defined as the degree of convergence or divergence of light rays can be achieved by a lens is called power of lens. Are you clear about definition? Is it clear definition? Why that definition is given like this? Everyone. So definition also meaningful. Blindly they cannot give, right? So it is the meaning of the definition, right? Then here we are having one more definition for this. Simply it is reciprocal of the focal length, right? Power of lens also defined as reciprocal of the focal length, right? So power of lens is denoted by the letter P here. Power of lens is denoted by the letter P. Then here, simply, I'm using a lens here. See, what happens if the parallel beam of light rays focused on it? It can converge at a point. So here, simply, I try to change its focal point towards left or towards right. So with the same lens, it is not possible, right? If I change the lens, its strength is varying. To change the angle, right? How much it can deviate that light ray. That is only here achieved by the lens called power of a lens here, right? So this point is what focus that you are able to change converging point inside or outside. If you use concave lens with this also, you are able to do the same thing. You are able to change its diverging point from that using the different lenses. So that converging point or diverging point not fixed for all. It varies from one lens to another lens depending on its radius of curvatures, right? Then we got it. Next here, we need to give its relation, I think, right? So what is the relation between the power of lens and the focal length? So I have definition, this one. What I gave you here, reciprocal of the focal length. Reciprocal of the focal length is given as power of lens. So using that definition, I am giving you the relation between the power of lens and the focal length. So P equal to 1 by F. But the condition is F must be in meters, right? If you want to convert that into centimeters, we can write the formula I is 100 by F in centimeters. 100 by F in centimeters, right? It is. Then we have one more question here. What are the units of power of lens? Actually, units are per meter or per centimeter, but here we won't use that. That is specially given as diopters here, right? Power of lens measured in diopters and that are denoted by the capital D. Diopters denoted by the letter capital D. Then here, power of lens is negative. Power of lens is negative for concave lens. Sir, how do you say power of lens is negative for concave lens? Simple here. Suppose if I take concave lens, right? Concave lens. Here, if you focus parallel beam of light rays on the double concave lens, after refraction, they can diverge or converge. They can diverge here. So here, if you go in the backward direction, they can meet each other at a point. That point only we are considered as focus. Here, the distance between the pole and focus is given as focal length. Then here the sign conventions are you are measuring the distance from pole to the focus and given as focal length. Then here you measured opposite to the instant light ray taken to be negative. So F always negative for concave lens. So here I'm going to substitute that F is negative value, something unknown. So what I will get? P equal to negative value. So that's why I concluded power of lens of a concave lens, right? Power of lens of concave lens always negative. Are you clear? Are you in confusion? Why I decided concave lens power of lens is negative? It is according to the sign convention and practically where we got that diverging point. Then tell me, what is the power of lens of a convex lens according to sign? Anybody? Unmute and give me your response. Unmute. Anyone? Anyone?
Sir, positive.
Positive. Why positive? Why positive?
Sir, all the rays will meet at a point in convex.
Right. So what the sign convention you can apply? So like this we are observing, right? Here simply you are measuring the distance between the pole to the focus here, right? Towards right side. It is in the direction of incident light ray. So F is measured as positive. So what we can conclude here, power of lens of a convex lens is positive. Are you clear about this? Are you clear about this? Yes. So here simply we are able to identify the defect or not by knowing the power of lens. If power of lens is prescribed by a doctor, positive. What the lens is? Power of
Convex
lens.
lens.
Yes, it is convex lens. If convex lens is prescribed, what is the defect?
Hypermetropia.
That's it. By knowing the power of lens, you are able to identify the defect and also identifying the type of lens. You have both information. You have both information, right? Are you clear everything what I discussed now? Yes, right? So now we'll go for how to find out the focal length, right? So before that, we have a relation here. What is that? P equal to 1 by F in meters and also 100 by F in centimeters. Always we are using 100 by F in centimeters formula, right? If compulsory, it is asked to express that in meters, what focal length, then you can use, right? So here you have two types of problems. By giving the power of lens, they may ask you to find out the focal length, or they may ask you to find out the power of lens by giving the focal length. Anything is possible, right? So simply observe here, doctor's advice is to use 2D lens. What is focal length? The question is given like this. Doctors advise to use 2D lens. What is the focal length? So what is given actually here? What is given actually here? Power of lens or the focal length? 2D.
Power
Of lens is given. So we know power of lens. That is what P equal to 2D. Is it positive given or negative given? Positive given. So P equal to 2D. Then power of lens formula is 100 by F in centimeters or 1 by F in meters. But here, what is given? 2D is given. We are always expressing the focal length in centimeters. So you can convert the formula as F in centimeters equal to 100 by P transposed. I'm using the second relation only, P equal to 100 by F in centimeters. By transposing, I written F in centimeters equal to 100 by P. Then I need to substitute that. So P is given as 2D. So 100 by 2. That is giving you 50. That is giving you what? 50. So what is focal length? 50 centimeters. Right? 50 centimeters. So I got F is equals to 50 centimeters. Are you clear how to find out the focal length by knowing the power of lens? Yes, right. There are other models also, right? So here, number of questions may be asked you like this. For example, they are giving you focal length in centimeters, right? They are giving you focal length in centimeters and ask you to find out the power of lens. Suppose here focal length is given in 100 centimeters. What will be the power of lens? So you need to find out, right? How to find out that? Here I am using the formula same 100 by F in centimeters, then 100 by 100 cancel. What is left? That equal to I got 1. So what is the power of lens? 1 diopter, right? If the focal length is given 100 centimeters, the power of lens is 1. If it is given you 50 centimeters, then I can calculate 100 by F. That is 100 by 50. Cancelling 52 times is 100. So that too we can use as here power of lens. Then calculate like that. Similarly, you will get 100 by 25 gives you 4. 100 by 20 gives you what? 5. Are you clear about the table? How I made? Right? So any value they may give you in the exam. Suppose power of lens is given as 6D. What is focal length? 6D. What is focal length? What is focal length? 6D power.
Sir, 1.66.
Right. No, 1.66, no. 16.66, I think. 16.33. Right? 16 times 96. Okay. Right. So this is about power of lens. So with these, the topics from the lesson number 5 are covered, which will come in your examination. Remaining part, prism, dispersion, scattering, won't come in your examination. That is activity-based lesson. Is it? Are you clear? Lesson 5. Give me your response. 5th lesson, any doubt? Defects or corrections? Defects or corrections? No doubt. Tejaswini? Yes, clear. Right? Okay. Then we'll start a new lesson in the next meeting. Join immediately.